Imagine for a moment that you are standing barefoot on a quiet garden path after the rain. At your feet, an earthworm inches its way through the soil, blind, soft, defenseless. The most dramatic event in its day may be drying out on warm pavement or being plucked from the ground by a hungry bird. Now imagine lowering yourself beneath the surface of the ocean into a world where worms do not wait to be eaten. Here, they are the hunters. In the sea, worms do not merely wriggle, they ambush, they paralyze, they dissolve bone. They grow longer than buses and hide beneath the sand like coiled traps. The same simple body plan, a tube of muscle, no limbs, no jaws worth mentioning on land, becomes underwater something altogether more formidable. Why is it that on land worms are humble recyclers, yet in the ocean they become monsters? The answer begins with one of the most infamous of them all. Beneath tropical coral reefs, hidden in the sand, lies a creature known as the bobbit worm. It can reach lengths of 3 meters, nearly 10 feet, though you will rarely see more than a few centimeters of it. The rest of its body is buried, anchored in a tunnel it has carved beneath the seabed. What protrudes above are 5 delicate antennae, gently waving in the current. They are not decorative, they are sensors. The reef is a crowded, restless place, fish darting, crustaceans scuttling, predators patrolling. When an unsuspecting fish swims too close and brushes one of those antennae, the sand explodes. The strike is almost too fast to see.
Jaws snap shut with astonishing force, and in a fraction of a second, the victim is dragged downward, vanishing into the sediment. The worm does not deliberate, it does not inspect. It cannot see in any meaningful way, only sense light and shadow. If something moves near its burrow, it bites first and determines the details later. Even prey that fight back, even those armed with toxins like pufferfish, may not have time to deploy their defenses. A swift severing bite can be enough. In many cases, the worm need only tear away a piece. Occasionally, it succeeds in hauling down the entire animal. For a diver, an encounter would be deeply unpleasant. A human finger brushed too close could receive a painful wound. Yet we are far too large to be dragged under. The true horror lies not in danger to us, but in how perfectly adapted this animal is to a violent world we rarely see. There are even stories of bobbit worms accidentally transported into home aquariums, hidden deep within coral rock. For months, sometimes years, they remain undetected. Fish disappear. Bodies are found neatly severed, and only later does the keeper glimpse a long, glistening form retreating into the gravel. On land, worms have no need for such savagery. An earthworm's world is rich in decaying leaves and organic debris. Its role is humble but vital, breaking down plant matter, enriching soil, sustaining ecosystems from the ground up. There is little competition for rotting leaves. No lions contest the forest floor for compost. And so earthworms survive not through weaponry, but through abundance. There are simply so many of them that total eradication is nearly impossible. But coral reefs are different. They are crowded cities of armor and claws. Nutrients are precious. Dead matter is scarce and quickly consumed. A single fish represents a feast beyond compare, dense with protein and energy. In such a place, softness alone is not enough.
To survive, a worm must become a weapon, and water itself makes this transformation possible. On land, gravity is relentless.
If an earthworm attempted to grow 3 meters long, its own weight would pin it helplessly to the ground. Its muscles would collapse under the strain. It would dry out and perish. But underwater, buoyancy changes the rules. The surrounding water supports the body, counteracting gravity's pull. Suddenly, great length and muscular power become viable. In water, a worm can be enormous and still move. Not all marine worms chose brute strength. Some evolved a different strategy entirely. The bearded fireworm is smaller, almost beautiful at first glance. Its body shimmers with color. Along its sides, delicate white bristles form soft-looking tufts. To an uninformed observer, it appears almost inviting. But those white filaments are hollow needles, thousands of them, each filled with potent neurotoxin. Brush against one, even lightly, and the bristles snap off into the skin. Venom floods the nerves. The pain is immediate and intense, described by divers as a burning that radiates and lingers, sometimes accompanied by nausea and dizziness. Unlike the ambush predator concealed beneath sand, the fireworm advertises its danger. Its bright coloration serves as a warning. It does not hide, it proclaims, "Do not touch." On land, such elaborate chemical weaponry is rare among worms. But in the reef, where predators sample anything edible, toxicity can mean survival. Then there are those that took size to an extraordinary extreme. The ribbon worm, sometimes called the bootlace worm, holds a record that sounds almost mythical. One specimen, measured in fragments along a Scottish shoreline, was estimated to reach nearly 55 meters, around 180 feet, longer than a blue whale, longer than any dinosaur we know. And yet it weighs only a few pounds. It is not thick, not muscular, not imposing in the way a whale is. Instead, it is astonishingly thin, a living ribbon. How can something so fragile survive? Its secret lies in physiology. Ribbon worms lack lungs or gills. They breathe entirely through their skin. By extending themselves into an extraordinarily long, slender form, they maximize surface area. Nearly every inch of their body absorbs oxygen directly from the water. In effect, the entire animal becomes a single vast respiratory membrane. When hunting, the ribbon worm performs a remarkable act. It everts a structure called a proboscis, turning part of itself inside out and projecting a sticky, often toxic ribbon to ensnare prey. Small crustaceans and other invertebrates are entangled and subdued. Length here is not for intimidation, it is for efficiency. By stretching through crevices and across the seabed, the worm can explore territory while keeping its vital organs tucked safely away. Growth in length requires relatively little energy compared to adding bulk. In water, elongation is cheap, and gravity, once again, is less restrictive. But perhaps the most extraordinary worms of all live far below sunlight at hydrothermal vents, places where the Earth's crust splits open and superheated mineral-rich fluids gush into the abyss. There, in total darkness, stand forests of giant tube worms. They can reach over 2 meters in height. Their red plumes wave in the chemical currents, and yet they have no mouths, no stomachs, no digestive tract at all. Inside their bodies is a specialized organ housing billions of symbiotic bacteria. These microbes perform a chemical miracle. Using hydrogen sulfide, a compound lethal to most life, they convert toxic vent emissions into organic molecules that feed the worm. It is a process called chemosynthesis. The worm provides shelter and raw chemicals. The bacteria provide nourishment.
Together, they flourish in a place that would kill nearly every other creature we have discussed. Freed from the need to hunt or digest, these tube worms grow with astonishing speed, among the fastest-growing marine invertebrates known.
And then there are the so-called zombie worms, Osedax, which specialize in a resource both rare and macabre, the bones of dead whales. When a whale carcass sinks to the sea floor, it becomes an oasis of life. Scavengers strip away the flesh, but long after the meat is gone, lipids remain locked within the skeleton. That is when Osedax arrives. Like the tube worm, it has no mouth. Instead, it grows root-like structures that burrow into bone, secreting acid to dissolve the mineral matrix. Symbiotic bacteria digest the fats within. The worm absorbs the nutrients through its roots, effectively drinking from the skeleton itself. Its reproductive strategy is no less strange. The visible individuals are females. Males are microscopic dwarfs living within the female's body, existing solely to fertilize eggs. They never mature, never leave, never feed independently. It is a life history shaped entirely by the deep sea, by drifting currents that carry larvae across vast distances, by the rare chance encounter with a fallen giant. None of this would be possible on land. Ocean currents disperse larvae across continents' worth of water. Buoyancy permits improbable size and shape. Chemical energy from the Earth itself fuels ecosystems independent of sunlight. In such a realm, the simple worm body plan becomes a canvas for astonishing innovation. And so we return to our garden path. The earthworm at your feet is not primitive. It is exquisitely adapted to its world, a quiet engineer of soil, a cornerstone of terrestrial life. It has no need for venom, ambush jaws, or bone-dissolving roots. But beneath the waves, where competition is fierce and gravity loosens its grip, the same basic blueprint transforms into hunters, chemists, symbionts, and scavengers of giants. The difference is not in the worm alone, it is in the world that shapes it. In water, evolution is given room, quite literally, to stretch, and when it does, even the humblest of creatures can become